So given here we are going to convert the PDA to CFG. Given a push-down automata, we want to convert that into a CFG. So for that, so this is the example of given PDA. We want to convert this into a context-free grammar. So context-free grammar consists of four tuples. So we represent it as G, and we are having variable, terminal, production, and the start symbol. So given this PDA, we want to first find the variables of the grammar. So the states given in the PDA is Q0 and Q1. So what are all the different combinations of these states we can able to get from these two states? So we can, that is what is going to form the variable, and also we have to use the stat symbols X and Z0 to form the variable. So we want to add over the start symbol S, and then we want to go with the combination. So Q0, Q1, sorry, Q0, Q0, and then Q0, Q1. Similarly, Q1, Q0, and then Q1, Q1. This can be taken for the variable X. That is, we are now having the variable Q0 x Q0, Q0 x Q1, Q1 x Q0, and Q1 x Q1. So all these forms the variable in the grammar. The other set of variables Q0 the same way, Q0, 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 Q1, Q1, Q0, and then Q1, Q1. We want to take here the variable stack symbol Z0, 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 and Z0. So these are all again. So total number of variables we are getting in this equivalent context-free grammar is 9. But all these are not going to be the useful symbol. After finding the productions, we want to remove the unwanted symbols which cannot be reached from the start state. Start state la endha symbol kulam pog mudiyadho adu ellame vandu unwanted symbols ah nam eliminate பண்ணிடணும். இதுல இருக்க எல்லா வேரியபிளுமே நமக்கு யூஸ் ஆகும் சொல்ல முடியாது. So that is what is the first step. That is we have find the variable. The next step is from the transitions. We want to find from the transitions of PDA. We want to find grammar productions. We want to find the grammar productions. So that is our next step. So on finding the productions for the grammar, the first thing is we want to find the production for the start symbol. So what then the production? Yes, we are finding the productions from the start symbol. So yes goes to, we want to take the variable from the start state of the PDA. So what is the variable from the start state of the PDA? So we are having the variable as well as the start state of the stack symbol. So what are all the possibilities? We are having Q0, Z0, Q0. This is one variable. The another variable is S implies Q0, Z0, and Q1. So this is the two possible variables. That is from the start state and from the stack symbol. So this is two productions which we want to add in a context-free grammar. The next possibility is so in a given PDA we are having two states, that is Q0 and Q1. The production given, the transition given to is Q0, 0, Z0, which gives Q0 and XZ. So the number of stack symbols here is 2. So total, the number of state here we are having is 2. So totally here we are going to get 4 productions for the grammar. Totally we are going to get 4 productions for this grammar. So on the left hand side of the production group, that occupies this Q0 and then this Z0, and we want to put all the possibility state Q here. Then we have to go with this input symbol 0 followed by this Q0 and then X. Then we have to go with all possibility of Q and one more symbol for Z0 followed by all possibility Q. And we are also all possibility. That means, so here how can we write how the 4 possibilities are here? So first we'll take here. So the possibility here is there comes Q0 and there comes Q1. So what is then the thing? So Q0, Z0, Q0 goes with 0, Q0, X, Q0 followed by this comes here, Q0, Z0 and this one comes here, Q1. The other possibility is, so again here we are having the possibility Q0, Q1. The other possibility is Q0, Z0, Q0 goes to 0, Q0, Q1, Q1 again the same, Z0, Q0. That is, this one has to come here. This is for taking Q0 over here. And this one is for here and this is for this one. So what is then the next possibility? We want to write for Q1. So what then the thing we are going to have? So again we are going to have Q0, Z0. We want to go with Q1 and we are going to have 0, Q0, X, Q0. Again Q0 is the same, Z0. Here we are having Q, so comes Q1. The same way Q0, Z0, Q1 goes with 0, Q0, X, Q1, then Q1 because the same, Z0, Q. So this is the 4 possible productions. 4 productions we are obtaining from this symbol group. So what is the productions we obtained here from this transition Q0, 0, Z0 is equal to Q0, X, Z0. The productions we obtained are Q0, Z0. We went with 4 productions. All 4 productions are starting with the same thing, Q0, Z0. And here comes the input symbol 0, followed by two variables, one for this stack symbol x, another for this stack symbol z naught, and this q naught has to complete. So all the productions are going to be like that: 0, q naught, and here we are going to have x, here also we are going to have x, here we are going to have z naught, here also we are going to have z. So here if we put q naught, then here also it is q naught. So here q naught, here also it is q naught. And here two possibility states. One is q naught, so here comes q naught. Q1, here comes q. The same way here we are trying for the another possibility. If it goes to q1, then here also it goes to q1. And again we are going with q naught, q1, q1. So this is the same way we want to try for the all next rules. So the next rule we are having here is del of q naught comma 0 comma x is equal to q naught comma xx. So what is then the equivalent productions of the grammar? Again we are going to have four productions. So what then the thing we are going to have? So q naught, and then we are having our x here, so x. Then on the right hand side we want to go with 0, then this q naught, and for this x, and we want to go with one more thing, that is for this particular x. So we are again going to have q naught x, we are going to have 0, q naught x, x, the same way q naught x, 0, q naught x, x, q naught x, x, x. So what then the thing comes here? If we put here q naught, then here also q naught, and we are going for the state q naught here, and here we are taking q1. Sorry, here we are going to take our q naught. These two productions are with q naught. Then here also q. Now here we are going with q naught. The other possibility is with the second state q1. Now we are going with q1 here. Here is also q1. Here q1. Then the possibilities. Next possibility is taking q naught here and here also q1 and q1. This is what's the possibility of the next four productions we are obtained by this transition. So we'll go for the next transition. So for this production, we are going to get for this transition we are going to get the production q naught x, that is q naught x q1 implies this input 1. For the next production, we are going to have q1, it is this q1, and we are having our x, and then this q1 which gives epsilon. Next production, we are having del of q1 comma 1 comma x is equal to q1 comma epsilon. So we are going to have the production q1 x, q1 gives us 1. So the next production is we are having a transitional still of q1 comma epsilon comma z0 is equal to q1 comma epsilon. So the production is q1 z0 is q1 gives us the epsilon. So we are to reduce the complexity, we are giving name for the variable. So finally, we are obtaining these productions so that it is easy for us to simplify the grammar. So we are finally we are obtaining these productions. So S implies A and S implies B. And now we want to find which are all, because we are having the variables now S, A, B, C, D, E, F, G and H. We want to find whether all the variables are having the left hand side, so that we can able to find which are all the variables that is not having productions. So here we are having S on the left hand side and A is also on the left hand side, so it is having production, B is having production, C is also having production, D is having production, and E is not having production, and F is having a production, and G is not having production, and H is having production. So we want to eliminate these two productions, that is productions having these two variables on its right hand side. So in the productions the E and H are the right hand side remove those productions. We want to remove those productions. So the productions are the production having E. So this is one production where we want to eliminate, and the other production where the G is appearing. So this is the another production we want to eliminate. So these are all the two productions we want to eliminate because this E and the G is not having productions. So we want to now take the remaining productions. So on considering the remaining productions, so after eliminating the production having E and G on its right hand side, the productions are this one, and from this productions we want to find the useless symbols or the productions that does not lead to terminal strings. So when we take our S implies A, we want to check for the production A. When we take our production A having only one production, and in that production on its right hand side A is again appearing. So this does not lead to, this definitely does not lead to terminal string. So we want to eliminate this production. Since we are eliminating this production, this one is also to be eliminated. And with respect to B, we are having two productions, and with this productions we are having B appearing on itself, and for B we are having one more productions. We want to check whether this leads to termination. S on substituting D for 1 and F epsilon, it goes with it, it produces the string 0 1. So this production is okay, and hence this one is also okay. This also leads to termination. So we are getting the productions S implies B, and then B implies O, D, F, and in this production B leads to termination. Now we want to check for C, whether C is leading to termination. So when we consider our C, we are having the production C implies 0 C, and C is having only one production, and the C is appearing again on its right hand side. So this definitely does not lead to termination. This also does not lead to termination. and hence we want to remove this production. So based on this, we obtain that A and C are not a variable in the grammar. So we want to eliminate all the productions involving A and C. So remove all the productions, remove all productions having the variable A and C on its right hand side. So we want to go with that one. So what are all the variable productions we are having C and A? So this one D implies OCB is not there. It should not be included. All others can be this one. B implies OCB cannot be included. So the remaining productions are the valid production. So what are all the things we are having here? So our answer is the equivalent CFG for the PDAs. S implies B, B implies ODF, and then D implies ODH, and or 1, and then F implies epsilon, and H implies 1 or epsilon. So this is what is the final answer we are obtaining for the given PDA. So thank you.